Hello and welcome to today's web seminar, How to Automate Testing for Next-Generation Interfaces, including web, mobile, and applications like Siri and Alexa, sponsored by InfoStretch and featuring Manish Mathurya, founder and CTO at InfoStretch, and Sunil Pillai, director of InfoStretch Labs. I'm your host and moderator, Josiah Renardon. Thank you for joining us today. Before I hand it off to the speakers, let me explain the controls on this console. If you experience any technical issues, please send a note through the question field located beneath the panels, and we'll be on hand to help as quickly as possible. Our responses can be read in the Q&A panel to the left of the slides. This is also the same way to submit questions. We welcome all comments and inquiries during today's event, so feel free to ask as many as you'd like. We'll answer as many as possible during the Q&A session after the presentation. Today's event contains polling questions and a video, which can be seen within the slide view. To optimize your bandwidth for the best viewing experience possible, please close out any unnecessary applications that may be running in the background. At the bottom of your console is a widget toolbar. These widgets open panels. The console opens with 3 on your screen: the speaker, Q&A, and the slide panels. All of these panels can be moved around and resized to your liking. If you accidentally close one, click the respective widget to reopen the panel in its original place. Hover your cursor over these icons to reveal labels identifying each widget. Through these icons, you can download the speaker's slides, as well as share this event with friends and colleagues. This event is being recorded and will be made available for on-demand viewing. Once the recording is ready, you'll receive an email with instructions how to access the presentation and slides on demand. With that said, I'd like to introduce and pass the controls to our first speaker, Manish.
Hi, this is Manish from InfoStretch. Good morning, good afternoon, good evening, everyone. Today we want to throw some light on the impact of next generation interfaces on our traditional testing and test automation models. As we know that we are really going into the hyper-connected world. Today we want to start and begin with the emphasis on how these new interfaces are impacting our life in terms of testing and test automation, and also want to touch upon that how are these systems are impacting the whole SDLC life cycle as well. Of course, then we want to talk about challenges which are involved around test automation. Today we'll mainly cover 2 aspects in these new generation interfaces is around mobile and bots. On the bot side, we'll take care of and talk about voice and the text as well. So let's go through a detail of what do we mean by hyper-connected world, right? So we know that in the past we had mobile device and there was a cloud behind it where we would transfer information or connected via some sort of internet. In this hyper-connected world, what we are seeing is that the mobile app is becoming the hub, literally a control panel for many devices, right? So if you think of it, I mean, we are now controlling our thermostat at home. We are getting synced with our Apple Watch or any other smart devices. We are collecting many data from different sensors. We are using camera like never before, where we are using for many different things, including QR code till PDF document making. So this new generation connectivity or hyper-connected apps are bringing different challenges in terms of how we have to test and how we can create a test automation around it. Now, everyone talks about omni-channel offerings. Majority of the enterprises we have seen has gone through the mobile 2.0, 3.0, whatever we call it. They also have traditional web presence, but at the same time now they are thinking of how can I leverage use cases around smartwatch apps, how can I leverage around new generation technologies which are of virtual reality. What seems to have picked up pretty well in terms of how can I have a seamless interaction with our customers. Lot of retails and new generation healthcare has tried to leverage smart TV applications as well. They are no more just a content display kind of mechanism. They are trying to use it interactively with many different use cases. So what we wanted to do today was we want to now talk about few or a subset of the challenges which are involved in this kind of use cases, and how do we test them. So let's look at some of the problem statements here. So we know that um, so let's ask one question to everyone. So I wanted to know is that how many of you are currently using any of the voice or bot interfaces in your products or services, right? Many enterprises have embraced it. Some are toying with it. Many are going through the ideation of try fast, fail fast. It would be very interesting to know what is your thought process around it. And this is, as we are seeing it, it's coming out almost equal. So it means some are trying, some are not, and some are kind of not planning to use it. Eventually it will come around. So it's very interesting data point we are seeing it. So as you can see, all these new interfaces are in the infancy stage at this point, but a lot of enterprises are toying with it. So let's look at some of the challenges we are seeing, which are of very simple in nature, though they bring a lot of complexity in terms of test and test automation. Many devices are connected using BLE. As you know, I'm sure every one of you are using it. Now we see that how do you test in automated fashion, connect, disconnect kind of things, if there's an interference from other devices, how if the device has a different protocol, how are you going to test it, how are the syncing happening, how are the online, offline is happening, how are the actions are getting generated. So traditional tool sets are not helping in this kind of scenario. So how do you test them? How do you automate them? Other question comes is, when there is many use cases use mobile phone as a camera, so how do you test them? How do you test the algorithms behind it? How do you test the OCR capability based on the use cases? So that is another challenges we are seeing it. The new one, most of the applications we are seeing is now tethered to location, some or the other fashion. They try to leverage location metadata. Now, when, let's say, for example, Uber, like how do you test those kind of scenarios using traditional testing methodologies? How do you simulate different conditions? How do you simulate the walkthrough of the locations, right? So now, what is happening is that as the testing and the tool sets are maturing, we are seeing that even the complexity of use cases are maturing, and we have to catch up to that. Also, though it looks, let's ask one more question. How are you currently testing your voice bot interfaces? It would be very interesting to know how are you doing it. I am sure it's not applicable to some of you, but I'm sure some of them are using it. As you can see, that automation is purely flat. I can assume that automation will be flat on this front because the tool sets are practically non-existent or very custom made, whereas the manual process would be still relevant whoever is using it. So as you can see the data, it's going on that front where manual is more compared to automation. So this is what we try to address in this webinar. Though it looks very simple that date and time is a natural things we need to test it, but the complexity of locale, date and time gets way beyond in terms of the use case testing and validation. So what we'll do is in today's webinar, we'll touch upon that, how can you do the automated testing around that as well. Now, of course, as you know, Apple phone and others are now trying to do the biometric authentication. That brings, how can you run a whole automation around that? So that's another area we want to target and talk about it today. So we can think through these scenarios. There are many, many more such scenarios. This is just a small subset of it. To deep dive into this, let me introduce Sunil Pillai, who is driving our labs to take and deep dive into these scenarios. Thank you, Manish. Hi, everyone. So what Manish just covered was to give you an idea of how complex mobile applications can really get, especially with the different interface points that mobile has today. And not only is it complex from a development perspective, but very soon we do realize that when you actually get into testing it, it gets equally complex as well, right? So let's kind of start looking at some of the challenges and strategies around testing them, and we start with mobile and then we move to bots. So what is really the challenge in mobile test automation, right? So the key issue essentially is around simulation. Simulating the behavior of a simple mobile app is pretty straightforward, and there are well-known patterns of doing it. But once you add different sensors around it, like location, accelerometers, etc., it gets very complex to figure out what the right simulation strategies and the tools around them should be. And then we have existing tools which are traditionally being used for automation. The problem is that they've been built for mobile first, but they've been built from a perspective of functional automation, and they don't really do well when you have to really bring in sensor level simulation. Then the third part essentially is that if you want to really do simulation around hardware for mobile, often developers do get into instrumented code where they actually write in some specific pieces of code to allow them to really test it when the binaries are out there. That works up to a point, but beyond that gets really complex and really unwieldy. And then finally, it's a mobile application. So how do you handle interrupts? How do you handle interrupts from either a incoming phone call? How do you handle interrupts of things going offline? How do you handle interferences, etc.? So all these put together really make testing mobile applications, in the context of a real usage in new generation interfaces, really complex. And that is why newer strategies are really important to help manage those. So there are multiple ways of really testing it out. What you see up here on the screen really is a glimpse of what are the different aspects that need to be tested. So you have all the way something like Touch ID and all the way to GPS and BLE, and each aspect of testing for this mobile app, it individually has to be done in a very discrete manner, and sometimes they can be combined together, sometimes they really need to be tested individually by itself, and all put together, testing them manually, as you can see, is pretty unwieldy, right? You can get some amount of coverage, but if you want to really get a good coverage for testing across these different facets, it can get really cumbersome and unmanageable. So what we've done, and one of the approaches of solving this is really using a mobile automation library. This is a library which can really reside as part of your mobile application package, which may not really need any code level changes. But this is a package which can be controlled by a backend interface, as you can see on the right-hand side. And you can really, at runtime, during your automation, decide what aspects of the testing that you really want to control. For example, you could set a cadence and say that, okay, my camera needs to turn on and off every 5 minutes and capture a specific image which you inject into your testing parameter. So this can be controlled by this package, by this mobile automation package, and the configuration can be all be controlled from the backend. So what that allows you to do is that, first of all, it allows you to bake this in as part of your regular automation that you've built in for your mobile application. Secondly, it gives you a level of flexibility in configuration so that a single mobile application, when it is used for multiple scenarios, can really be tested to the same package without having to make any code level changes. And what this suite approach really shows is that this is a very modular suite, so you can really add on more interfaces in the future when they get added to the entire mobile spectrum. So you can imagine that Touch ID was not really relevant till probably the last couple of updates of iOS. But then this is a modular suite where you can really keep on adding more functionality. And the way this mobile architecture, and I'll show you in the next slide, I'll show you an example of how this can be leveraged. But really the way to look at it is that you have to really have a way of solving your automation strategy in a modular form, in a non-intrusive form, and in a configurable form. And this strategy really allows you to achieve all the three together. So let's kind of move forward and take a look at an example of how one of these would really work. But before we even go there, the other important piece to remember is that whatever automation strategy you use for your mobile application testing with all its peripherals, they need to be baked into your current CI approach, for example, right? Because you have built out your CI for your current mobile application, and you cannot be doing testing for these aspects of mobile in a very different manner. So whatever binary is created needs to be packaged with the right framework and needs to be built as part of the same CI process that you have in place. And entire thing should be seamless. So your final reports that you get out of your testing should not only include your functional testing, which you always had, but should also include the additional testing that you want to have as part of the process, right? So what does one example of such an automation look like? So let's take a case of location. So location is pretty ubiquitous in all applications, and an example here is where it's a field service application where a particular job is assigned to a field service personnel. The requirement is that the job really needs to get active only when the person really reaches a particular location. So it's an example of geofencing. Now, to test it manually really would mean that you need to have a way of really trying out different methods of geofencing in a real location, which can get really complex when you start doing it manually, right? And you cannot really spoof locations pretty easily. So either you have manual testers who are really trying to actually physically move locations to kind of simulate this environment, or you try to use some kind of a spoofing mechanism, which kind of maybe achieves your purpose to a point, but it's really not scalable and it's very brittle. Right? So by using this mobile automation framework, what you can really do is you can have this entire testing as part of your package in a very configurable form. And what this could look like at runtime is what we'll show you in the next slide. So what you see here is an animation of a real testing that's happening through automation. So as you can see that the location, the dot represents the location that the person is changing, and this is all done through the automation mechanism. And as soon as the person reaches a particular point, which you can see by the through the highlight, the next screen comes up automatically, which indicates to the which basically indicates to the automation that okay, now is the time to trigger a use case. So this entire testing of actually changing location from one point to the other and bringing up the next trigger point, which is the screen in this particular case, was all done through automation. And if you had to do it manually, it would have to, and remember that this is just one flow that we really tested out, but you can really scale it out to multiple different flows and in a very easy manner. So this is an example of how mobile automation frameworks can really help you to automate your interfaces. Now, having talked about mobile, which is pretty important, let's move on to another channel which is getting pretty pervasive now, and that is essentially bots. And in the next few slides, I would like to cover different nuances about why does bot testing and automation of a bot really is different, and what are the different challenges that it introduces, and what could be strategies for really testing it out. So when you look at bots, just to put some terminology in place, there are two different kinds of bots. Chat bots, which are also known as text bots, so text-based bots, which you can see on the left-hand side, and the other one is voice-based bots. So in both the cases, really you have an automated mechanism on the back end, which is listening to queries and responding to queries. On the front end, either your interface is through text or it's coming through voice. And I will explain in the next few slides some of the nuances between both of them and why we need slightly different strategies on how we want to kind of help test out these bots. So one of the main things that bots really introduce and what that has changed is that the UI is now really got blended with the parent host systems. So what do I really mean by parent host system? Bots typically reside in a parent host, like either it could be a Facebook Messenger bot, it could be a Telegram bot, it could be a Skype bot. So in this case, your normal conversation channels like Skype, Telegram, Facebook, they become your parent host. And the UI for the bot is really the UI for these systems, that there is no real specific UI that these bots really need to build out. For example, a bot residing in Skype is just a contact in Skype, right? Or for example, a bot residing in Facebook is just a contact in its messenger. Hence, the testing for these bots is more around flows and less around UI. And then you have UI which is conversational in nature. The conversational UI is different than your regular web-based or mobile UI because it's less rigid and it's more fluid in nature and can really change on the fly, sometimes based on cognitive parameters. And these need to be accounted for during your testing process. So what are some of the nuances of bot testing? It it is best to look at bot testing in two different aspects. One is common factors and another specific factors for each bot. Every bot needs to be tested for two things. One is called intent validation and response validation. And I'll talk about what each one is in the next couple of slides. But then there is also a specific factor that needs to be kept in mind. Specific factors are things which are very unique to that particular bot that is being tested. So all your testing and automation approaches need to have a layered approach. So you need to have a framework layer which really tests for commonalities between across all the bots around intent and response. And then your additional effort for testing should really be around building the specific automation for the specific factors of the bot. You don't have to reinvent the wheel every time. And by separating it out this way, it helps you achieve what is called as modular automation, and also helps you scale your automation in a very easy manner. So let's look at intent validation essentially. So intent validation is all about looking or listening to or reading a user's question and trying to figure out what is the user trying to say. So natural language processing, or NLP, becomes a very big part of intent validation, and hence your testing for intent validation not only needs to be looking at keywords that needs to be processed against expected intent that the user is trying to say, but also needs to account for natural language processing based automation that also is very important. And some of the questions that we need to ask here is that what is the threshold where NLP should really be failing, or what is the threshold at which NLP should really kick in? What are the boundary conditions for your intent that you need to test for? So these are some of the aspects that are very important for intent validation, which will become part of your common automation layer. The next is response validation, and response validation is really very important, because responses in bots, as you can see, in the animation there, a response can either be a question that the bot asks, or it could be an actual endpoint response that the bot gives you back. For example, if the user types in, I want to watch a movie, most of the intelligent bots are going to respond back saying, okay, what kind of movie do you want to watch? And so that becomes a question. And eventually it ends up being a response that, hey, this is running near you. You can probably go and catch a show today, right? So you have that nuance around response. And response validation automations can be built around current backend web service automation. Because if you think about responses are basically data that's coming back from the backend bot intelligence. So if you have existing backend intelligence which is built for other purposes, which are going to be repurposed for bots, response validation has to be built on top of them as a best practice, so you can leverage a lot of the backend intelligence that's already been built out. And responses can also be auto-triggered. For example, you could have bots which, on your birthday or on specific days, they actually send out messages saying that, hey, today there's something that you would be interested in. Would you want to kind of look at it, right? So you want to build response validation keeping these into account. Let's look at some of the very specific aspects of responses that really need to be tested. So as you can see, response validation and automation for those is not monolithic. It is pretty multifaceted, right? So you have things around. You could have a same query laid out, but you could have multiple responses come out, right? So you could say, yes, or you could get a response which says okay, and you need to be able to support your validation needs to be able to support all that. You also need to be able to kind of look at errors and typos coming in and kind of process that for your chatbots in the right way, right? Users can put in multiple queries in a single sentence, as it says there, because users are used to fluid conversation and they want to kind of mimic that with the bot. So your chatbot automation cannot be naive enough to think that it's going to be pretty rigid and one question at a time. You need to account for multiple queries in a single sentence. And you could have mixed languages eventually, right? So when you actually have global bots, you have to support multiple languages. So the challenges with translation-based automation carry forward to bot also, but they just get accentuated to some extent. And then you have to also think about response times for bots. So when you actually do bot validations during testing, it is not only about actual responses coming back, that is the content, but it is also the latency for the response, because in a fluid conversation, those are very important for a great experience, right? So if you look at these aspects here, it's pretty apparent that if you have a very manual way of testing out chatbots, it will only help you to a point, and after that it gets really complex and unmanageable. And hence the kind of automation is definitely indispensable. So what are the approaches that you could take for your automation? So you could break this up into two different parts. One is where you're kind of trying to really follow user action, which we call imitating user's action. The other option is headless-based testing. And the next couple of slides will give you some strategies around why each one is important and where you could use one over the other. So what is imitating user's action? So here, as you can see on the screen, it is a bot that is being tested, and it actually is tied to the UI for the bot. Now this, the way the strategy could help is that you have some kind of a data file, like an Excel spreadsheet, a CSV file, which has got your user flows defined, and it goes into an engine, an automation engine, which could be built on top of Selenium or any other framework, which then runs your actual bot. Now, obviously, it is pretty apparent from this approach that this will work great when you have to really test one bot for a particular channel, because you are really tying yourself to the actual user action, which could differ from different channels. For example, this particular screen that you see could look differently when it's on Skype versus when it's on Messenger. So you are tying your approach to a particular bot platform. So the other approach, when you have multiple bots, so let's say you have your bots that you're building for multiple platforms. You want to have it on Skype, you want to have it on Messenger, Telegram. What is the right approach to take? So you could have a headless approach of testing. So headless testing is a well-known paradigm in regular mobile and web testing, where you really want to remove the the variances in UI from your testing approach and really try to test out the logic. And there is an approach that you can really use for really testing your bots too, right? So you could have a data file which is the same as the previous case, which is a bunch of flows, and you can actually send it through another bot maybe, which is connected to your main bot, which actually goes and processes all your intents and responses, and then creates a final output. The biggest advantage of something like this is when you really don't want to tie yourself down to the UI of a particular bot, and you want to kind of open it up to more different kinds of testing. So between headless and UI, the way to look at it is that, if you really want to build out a scalable automation framework, it is okay to start with the UI-based testing, where you're testing for one bot, and then you can put in a framework in place where you have a mix of UI and headless testing, where in the UI piece, you're really testing out some of the finer UI aspects of bot. Right? So earlier I did mention that we are almost getting to zero UI configuration, zero UI paradigms for bots, but some of the bots you would see have got specific UI widgets which are sent back as responses sometimes. So your UI-based testing can really be catering to those, while your basic flows and logic, the heavy lifting of the bot, can really be tested through your headless approach, right? So that could be a good way to kind of combine both of them. So having looked at different approaches, one of the important aspects around bots also is, how do you really create these data files? Right? So remember, the bot flows are conversation in nature, right? So these are all these are flows that you want to really mimic in a very easy way. And it makes sense for a product manager or a business analyst to be able to easily write these flows in a simple Excel maybe, and then have an automation tool which can really suck it up and start processing these files in a very easy manner. So there are multiple ways of doing it. You can either use plain Excel, as it shows on the left-hand side, or you can create mind map diagrams, which can then be processed and converted to JSON format, for example, and then be fed into an automation tool. The important thing to remember here is that the time between creating these files for testing and actually testing should be minimized and automated as much as possible. If you have to sit and convert an Excel created flow into a bot specific language for your testing, then you have a lot of lost in translation, and also a lot of complexities that you introduce in the process. So we need to have an approach where you can take these files and have it feed it into your automation tool, and it processes it and gives you the results that we talked about earlier. And these are some of the strategies that that we use to help with bot testing for some of our clients. So we talked about bots, and when I talked about bots, mostly they were about text-based bots or chat bots, where the interface is text. And then now we talk about a little bit about voice-based bots. And the reason why that's important is because voice-based interfaces are getting pretty common, and they are going to become part of a lot of products that are going to be out in the future. So having a testing strategy around it is very important. And why is it important to look at voice-based bots separately from your regular text-based bots? The next slide will cover some of the nuances around that. So if you look at the complexities of testing voice bots, all the complexities that we talked about for testing text-based bots do exist, and they do carry forward. But then you have another layer of complexity that we need to think about, right? So we're talking about speech here. So when you talk about speech, there are variances in speech which cannot be discounted and undermined and cannot undermine your test automation. So we start with accents, for example, right? So mostly in our testing process, when we do test voice-based bots for our clients, we do find that accents are one of the prime causes when bots typically fail. And so no matter how much you've trained your NLP and your bot to kind of take care of different accents, a lot of testing needs to happen around it, and hence that needs to be factored in. You could, in case of voice bots, it also, you could say different things, but it could mean the same thing. For example, you could say yes, you could say yeah, you could say true, and everything else, and it all really means the same intent. In text-based, it's very easy to process those, and you can map multiple utterances to a single intent. In case of voice-based, not only do you need to do that mapping, but you also need to be able to interpret the voice aspect of it in a very easy manner, right? We talked about pronunciations already. Punctuations are a very interesting aspect of voice-based testing. It's an idiosyncrasy of voice-based testing, which is very specific, and that is because of the way it is set. And I've got a couple of examples out there which will give you a feel for why punctuations are important in your testing, because intents could totally be different if you don't process those the right way. And one of the other important factors which in voice-based testing is around background noise and interferences. So remember, your interface point in these cases of bots is really your speech, and the airwaves, and some kind of a device processes it, right? So background noise, which are prevalent all throughout, are very, very, they can really be more than ready to kind of damage any kind of voice-based intent processing that's happening. And hence your testing needs to have a lot of conditioning built in to really take care of background noise effects. And then you have the effect of distance. So in case of voice, for a real voice-based application to really work in an effective manner, it needs to be agnostic of movement from the user. And hence your testing around voice-based interfaces need to account for that, right? So you cannot expect a user to be sitting at 10 inches from a device and speaking to it always, right? The speaker is moving around the room, and if you do not reflect that in your testing, in your test automation, you are missing out on a very important condition for testing. So hopefully this particular slide gives you an idea of why voice-based testing adds another layer of interesting complexity of testing, and hence automation of voice-based testing becomes equally complex. So manual testing is pretty unwieldy, as we mentioned earlier, and automation really needs to account for these aspects. And the next slide will give you an idea of what something like that could look like. So in this particular slide, you could see that you have some kind of a device. You have some kind of a device that really it's feeding in. You're feeding some data to, right? So in this case, I'm showing an Amazon Echo here. You have a test suite which has got your test cases running in sequence. Now the test suite could really be the same test suite that we created for our text-based chatbots. Right? But then you have the layer in the middle which is really doing your TTS, which is your text-to-speech now. Right? So you really need to be able to kind of feed in the kind of speech you need to be processed, and either you can have pre-recorded speech that you want to run through your automation, or you can have text which gets converted to speech in an automated manner. But that becomes a very important layer of testing, because you need to create speech. And then the last piece is really some kind of a robot environment to really affect conditioning. So what the robot is really doing, and this one shows an example of TurtleBot, is you need to use it for changing distance from the actual echo in this particular case. You need to be able to use it to add different kind of noise interferences. And so you are creating a very real-time, real-life conditioned environment where your voice bot is being tested. So these put together really is an approach of doing an intent validations around your bots. And as you can see, if you built, and that's what we typically do, that if you build our automation strategies for chatbots, we then add a layer of conditioning and TTS for voice bot, and they both together work in a very harmonious fashion. So you don't have to reinvent the wheel for creating a lot of your flows again. So this is one way in which voice-based interfaces can be tested. So with that, that kind of gave you, hopefully that gave you an idea and a feel for the complexities around bot testing, both chat and voice, and why manual testing is not a scalable strategy for sure, and why your existing testing paradigms need also to be changed. And at this point of time, we just want to know if anyone's interested in our testing. But now we can move to Q&A.
All right, thank you so much. Now, before we start Q&A, maybe you can ask Manish and Sunil questions by typing them in the field beneath the panels and by clicking the Submit button. We'll try to get through as many questions as possible, but for those questions we're unable to answer live during Q&A, some will be answered offline. All right, let's start right here. This person asks, how do you see test automation frameworks evolving to support these newer interaction channels?
Sure, I can take that. So the current test automation frameworks were really built keeping web and then of course mobile in mind, right? So as you saw, a lot of the concepts around test automation do not really change. So the fundamental concepts still remain true. But what they need to be done is they need to be augmented with a very specific set of specific nuances for bots, and that's very important. So then there'll be scenarios where we really need to build test automation frameworks ground up. And at InfoStretch, we do both, where we do augment existing test automation framework, but we also have built ground-up strategies for very specific nuances of bots. So that's how we see it evolving, actually.
All right, great. Thanks so much. We have another really good question here. This person asks, can you run an automated check through multiple tiers, for example, the server and the phone, to verify a business requirement that touches on both tiers?
Absolutely. So, automate. Now, there's multiple ways of doing it, right? So you can have an automation that you run, which really tests only one particular layer if you want to isolate the problem. But most of the end-to-end automation really needs to be tested across both the tiers, right? So, for example, if you're running a mobile automation for location, as we saw today, it is a combination of multiple things. You have location changing on your phone, but then you also have your backend responding to the change location in sync. And what you're really testing through this process is not only how does your mobile app respond to your change location, but how does the content that comes from the backend also respond to a change location which is sent back as a parameter to your backend web service, right? So these strategies definitely can cover your entire stack all the way from front end to the backend.
All right, great. Thanks for clarifying that. We have another good question here. This person asks, what are some test automation tools that you would recommend for test automation of voice bots?
So it's a very good question, and the answer is pretty short too. Is that there isn't a single tool out there which exists which solves that problem today. What we've done at InfoStretch is we've actually built something ground up to really solve this particular problem. For example, right, you could let's say using Appium for testing a mobile application. Now, if you try to use it for voice bot, you would see that some of the aspects around NLP processing, etc., needs to be built outside your current automation tools to do it. So the short answer is there isn't a tool out there which does it today. And hence we had to build something ground up to kind of help solve the problem in a generic fashion.
All right, great. This person says, would you rely more on other bots such as Google or Bing voice APIs, or go the route of ground up to do any voice automation?
So if I understand the question, right, I think so maybe there are two parts in that question. So one part is that in terms of voice bot automation, eventually we could end up using some of the backend services provided from for example, when we do testing on Alexa, we do rely on Alexa's intent processing engine as part of the bot automation framework. So it is best to rely on those frameworks which provide you, either Google Home provides you the core APIs with their actions, or with the skills through Alexa. You have to definitely rely on them. But you need to build a layer on top, which is your orchestration layer for the entire voice or bot automation, and which provides you control for the flows and also for the kind of intents and the triggers that you really need to control, right? So it is a combination of both. You would not definitely want to build something completely ground up so that you're not relying on these in existing voice APIs at all, right? That would not be a good strategy. And when we build our frameworks, we really make sure that the orchestration layer is something we control, but we do rely on the underlying frameworks because eventually a bot is going to be used by these, are going to use these frameworks anyway.
All right, great. This person here asks, what would be the key differences in the testing approach for a responsive website versus a mobile application?
So I think the main difference is that when you're looking at a mobile application, and by the way, mobile applications can also be responsive in nature because you could have for tablets and mobile phones too. The main difference is that in case of mobile applications, you have a lot more control on the UI because you have kind of created it for a particular screen, for a particular flow, etc. In case of responsive web applications, you are not only testing for different form factors for responsive web, for example, a web on a mobile phone versus a tablet for a desktop, but you also have to deal with multiple different browsers on each of these machines. So you are looking at a combination which is pretty complex for testing responsive web because you could use a Safari on your mobile phone, or you could be using an IE11 on your desktop, and your application needs to support all of them. So I would say that really increases the complexity of how you really test it, and that is one important difference in how you do it.
All right, thanks so much. We have another good broad question here. This person asks, where would you recommend a testing department that is entirely manual now begin venturing into automation methods?
Got it. So that's another great question. Now I would say that and as you saw from my previous slide, the manual testing for these bots are going to get really complex, right? So what I would recommend is that this department and these engineers need to familiarize themselves with the tools that can be used for automating bots, and then focus on some aspects of this testing which would initially remain manual, but then rely on a lot more on the tools, so that you are doing a lot of the repetition. Let the tool do a lot of the repetition testing, and then the manual tester should really focus on the flows and the functional aspect of it, right? So that becomes a very lethal combination of testing bots. So the short answer is that the focus should not turn more to the flows and the functionality of the bot, and rather than the nitty-gritties of the bot itself, and let the tool handle it.
All right, thanks so much. And if you do have any more questions, please submit them in the Q&A box. We'll wait for just a few more to come in. Before we do that, I wanted to just make sure we got over to this slide right here because just give you guys a chance to kind of wrap things up, and then we'll have time for maybe one or two more questions.
So I think, yes, so, thank you to everyone who attended the webinar today. So if you have, challenges around your voice or bot testing, we'd be more than happy to, talk to you and, help you solve your problem and show you different strategies that can help you, achieve that. And you see the number and the email to reach us at, and great to speak with you.
All right, thanks so much. And we just had one more question come in, so we'll do this and maybe one last other one. This person asks, what types of automation applications would you recommend when testing the IVR or NLU?
Again, in terms of automation of, it's the same, probably on the same lines that I answered earlier, is that, there is no single tool that you can even test IVRs with today. The testing for IVRs is not very different than testing for voice bots. The only difference is that IVRs tend to be more rigid and well laid out compared to voice bots, which can be more fluid. But the complexities of testing And there's one more difference actually. IVRs may have less of a conditioning problem than bots because in IVRs you're typically on a phone, you're speaking into it, and you're very controlled environment. While bots, you could be on the move, you could be in a room, in a crowded environment. So the automation approaches though of having a workflow defined in some kind of an Excel spreadsheet fed to an engine, which then feeds in the right text to speech, which can be processed by the IVR. That should not change. And there is no single tool that can do that today in an easy fashion, right? And similarly, if you're looking at natural language processing, there is no easy tool to kind of process those today too, and they have to be built ground up. And hence, we kind of built some frameworks to help with the processing as part of the voice-based testing.
All right, thanks so much. That ends our event for today. I'd like to thank our speakers, Manish and Sunil, for their time. I'd like to thank InfoStretch for sponsoring this event. Also, a special thank you goes out to you, the audience, for spending the last hour with us. Have a great day. We hope to see you at a future event.